this is the fixed and fluidized bed unit. So as you can come closer, you will see that this is where we monitor the pressure drop. So now we can switch on pump 1 is basically for liquid. So this is the liquid. Inside here is the sand, and so we are going to change using this valve in order to change the sand height, which we have seen in the experiment just now. So this one is compressor. Compressor is for air, where we control the flow rate of air here. So we control it by seeing at this level to desired level, and we are going to see the height of this amount here. So basically this is a simple experiment. So the intention is to know the height of this sand, and so this one is at this, and monitor the pressure drop. That's all.
So nak naik 1 point. Nak naik mana tak? 1.0.
Assalamualaikum and good day, Doctor. For this video presentation, we will be presenting on experiment 10 and 11 about the effect of flow rate on solid liquid fluidized bed system and effect of flow rate and packing height of solid gas fluidized bed system. Before that, I would like to introduce myself. My name is Nur Ain Zulaika binti Zulkifli, and my group members which are Satya Rao, Alia Ayuni, Muhammad Faiz, and Tengku Nur Ain Nadia. So, we will start with introduction. A small laboratory fluidized bed reactor is used to test the chemical reactivity of solid particles fluidized with a gas and a liquid. The equipment is designed to allow the study of the characteristics on how the fluid flow through both fixed and fluidized bed (FFB) of solid particles. In gas-solid system, there will be a phenomenon of bubbling that occurs when the gas velocity is in excess of that required for fluidization. The transparent wall helps to study the bubble behavior in the system. So the objectives of this experiment are to determine minimum fluidization velocity, thus recognizing the point where the packed bed is set to start fluidizing. Second, to measure pressure drop across a packing material when the fluidization takes place. And third, to observe the effects of different pack height on the fluidization behavior of a solid. The bed expansion and the pressure drop of the particle are proportional to the superficial velocity of the gas supply.
In theory, fluidization is a condition where the solid particles are suspended in an upward flowing stream of fluid. And the fluid can be both gas and liquid state. At low velocity, the drag force on the solid particle is also low, causes the bed to remain in a fixed state, or also known as a fixed bed. At certain critical velocity of the outward flowing stream, the upward drag force is equal to the downward gravitational force, causes the solid to become suspended and in fluidized state. The transition from fixed bed to fluidized bed is defined by the minimum fluidization velocity UMF. As shown in the slide here, the formula for the UMF is equal to the Reynolds number times to the viscosity of the particle divided by the particle diameter multiplied by the density of the fluid. Fluidization also can be defined in terms of a gun equation to describe the flow of a liquid through a packed bed. Delta P is the pressure drop, and the G here is the mass velocity, while the symbol here represents the void fraction of the bed.
My name is Satyarao. So now I'm going to present the results part for this experiment. So basically for the first part of the experiment, which is the experiment 10, we are going to see the effect of flow rate in the solid liquid fluidized bed system. So basically the type of solid used in the bed, the solid particles used in the bed is sand, and the liquid was water flow rate. So in this experiment, we are manipulating the water flow rate, and the observed or responding variable is height and also pressure drop. So we could see a clear increasing trend in this result. So as the water flow rate is increasing, the height and also the pressure drop is also increasing. So now we are going to look at the part B, which is experiment 11. So for the experiment 11, we are going to see the effect of flow rate and also packing height on the solid gas fluidized bed system. So basically in this experiment, the particles in the bed is manganese silicate and the gas is air flow rate. So if, in this experiment also, the air flow rate is manipulated, and the observed and also responding variable is height and also pressure drop. So as we can see here, as the flow rate increases, the height and also the pressure drop is also increasing. So now we are going to see the sample calculations used in order for us to calculate the minimum fluidization velocity. So before we go into detail into the calculation, so I just want to explain what is minimum fluidization velocity. So it's basically where the drag force of the gas is equal to the weight of the particles. So basically it's like where at a point where all the particles become suspended. So in order for us to calculate that, we need to find the Reynolds number, and we need to use the Reynolds number in this equation, so that we can find the minimum fluidization velocity. So this is for the part A, where minimum fluidization velocity in solid liquid fluidized bed system. So we require certain parameters. So we put it into these equations, and after we get the Reynolds number, we can find the minimum fluidization velocity, and this is the value 0.00998 meter per second is the minimum fluidization velocity in the solid liquid fluidized bed system. So for the part B, the minimum fluidization velocity is as you can see here, it's 94.663 meter per second. So that's all for my part. Thank you.
Hello, my name is Tengku Nur Ainadia binti Tengku Syaiful Bahril. My matrix number is 192436. So today I will discuss on the results of these two experiments. Okay, there are two parts to be discussed, which are part A and part B. Fluidized bed using fluidization process where particles will move upwards with force through a bed of granular particles. In part A, which is about the effect of flow rate on solid liquid fluidized bed system, the relationship is that as the flow rate of the water increases, the height of the sand will increase, and the pressure drop also will increase too. To be discussed graphically, the pressure drop increased linearly with the water flow rate. For part B, which is about the effect of flow rate and packing height on solid gas fluidized bed system, the patterns of the recorded results are same with part A. When the flow rate of the gas increased, the height of the manganese silicate increased as well as the pressure drop. So next, a calculation of Reynolds number helps in obtaining the minimum fluidization velocity of both processes. In order to calculate that, the density of both state materials, particle diameter, and the viscosity of air and water are needed. The particle diameter for part A is 0.0018 meter and for part B is 0.00018 meter. The minimum fluidization velocity is necessary to be calculated due to stabilize the system. The particles will keep on moving upwards at the point when it is unstabilized. It is important to know the minimum velocity of the fluidization process, where from fixed bed can transform into a fluidized bed when it reaches the minimum fluidization velocity. For part A, the minimum fluidization velocity is 0.00998 meter per second and 94.63 meter per second for part B. For solid gas fluidized bed system, when the moving particles reach its minimum fluidization velocity point, bubbling will occur. So that's all. Thank you.
Hello, my name is Alia Ayuni binti N Manasil. My metric number is 182434. So for this experiment, I will present about the conclusion. In conclusion, based on the results obtained for the part A experiment, which is the effect of flow rate on solid liquid fluidized bed system, as the water flow rate increase, the pressure drop will increase too. However, it will become stable after reach the minimum fluidized velocity. While for the part B experiment, which is the effect of flow rate and packing height on solid gas fluidized bed system. So, as the flow rate of water increases, the packing height of material is also increases. The minimum fluidization of velocity of solid liquid fluidized bed system is 0.00998 meter per second, while solid gas fluidized bed system is 94.63 meter per second. In this experiment, there is a few recommendations in order to improve the result obtained. Firstly, we have to check the leakage on the connectors before we start the experiment in order to sustain the pressure of the fluids. Secondly, to avoid parallax error, make sure the eye is perpendicular to the scale when taking the reading of the height of packing material in the column. Next, make sure the fluidized bed system can function well before start the experiment and report to the lab demonstrator if there is any problem with the fluidized bed system. Lastly, take several readings of data and average the reading of data in order to reduce the error. That's all from me. Thank you.